We're all set. We're all in degree mode. So again, just let me repeat what I said for the people watching the recording. Days 8, homework day 8 and 9 are due tomorrow. Homeworks day 8 and 9 are due tomorrow. All right, I'm going to skip around here. Can you start on day 8, but go to question number 3 for me, please? Question 3. I just want to make sure I can do this today. I can do day 8 and 9 on the same day. We're still using sine, cosine, and tangent, except in word problems. So I am not teaching you anything new. All right, I'm not going to teach you anything new. It's just looking at a word problem and trying to figure out what's the best for me to use here, sine, cosine, or tangent. Okay, I am not teaching anything new. We are still using sine, cosine, tangent, but in the form of a word problem. All right, right away here, I have this diagram. It's an access ramp. I put in 4.76 degrees down here. First question is, state the length of the ramp to the nearest tenth of a foot. All right, we see the ramp? All right, just so we're all clear, the ramp is here all the way up there. All right, that's the full length of the ramp. So that's what I'm looking for, that full length of the ramp. And you'll notice I do have a right angle here. All right, those are vertical and horizontal, so I do have a right angle. And I started you guys off with a pretty tough problem. All right, finding that ramp. All right. Is there any... I don't want to give anything away here, but I know I'm going to have to use that 4.76 and maybe some combination of these 6 and 8 inches over here to find the length of that ramp. You want to talk it over with your group real quick, and then we'll come back as a full group and talk what's my plan there to find the ramp. I know I'm going to need a right triangle, right? And somehow involve that 6 and 8 inches. Okay, let's come back and talk. Let's come back and talk here. So we're writing down the correct work here. I did mention before I let you go in your groups, you are going to need a right triangle here, because I can't do sine, cosine, or tangent without a right triangle. And where we get our right triangle is right here. Where the ramp is going to act as our hypotenuse. Now you'll notice I still don't have any side lengths. I need at least one side length to do sine, cosine, tangent. Where am I going to get the side length from? Right here, this leg. Because I notice if I have 6, 6, and 6, I'm going to have 18 inches right there. So that's where I get my side. All right, now let me turn this over to you guys now. Going from the 4.76, I'm going to need to know what ratio is the best for me to use. Sine, cosine, or tangent. All right, so let's talk and find out. Here we're going. Theo, you're up here. What's the 18? Opposite, adjacent, or hypotenuse to the 4.76? It would be opposite. And how about the ramp I'm trying to find? That's the hypotenuse. So Theo, if I have O and H, which ratio am I allowed to use? SOHCAHTOA? Sine. Good. I can use sine. So I'm going to say sine of 4.76 equals opposite 18 over hypotenuse. You can call X H. I'll call it H there for hypotenuse, I guess. You can call it any variable you want, except for D in this case. All right, let's cross multiply. We got 18 equals sine of 4.76 in my case times H. How do I get rid of the sine of 4.76? We did a lot of these yesterday here. Where am I going with this one here? Adidia, how do I get rid of it? The 4.76.
You have to cross
I already did. I'm at 18 equals sine of 4.76 h. I want to get h by itself. What do I need to do with the sine of 4.76?
Oh, you divide on the other.
Divide both sides by sine of 4.76. Hopefully you're in degree mode, and hopefully you haven't rounded yet. What do you mean? Why can't I round? I'm at the end of the problem. I tried to warn you yesterday. Tried to warn you. What's the issue here? Everyone just overlooked it again. We got to be more careful going forward now. Gage, what's the issue? This is in inches, right? This is in inches because you just put 18 here, which was in inches, but it said round your answer to the nearest tenth of a foot. So what am I doing with my 216? Yesterday, you guys had me multiply by 12. Is this one where I want to multiply by 12? No, because I'm going from inches to feet. So I want to divide this by 12. And now you can round. Okay, now you can round. How's it look? 18.1 feet?
Yeah.
18.1. There it is for the ramp. A lot going on that one, huh? A lot going on. All right, let me get rid of all this now. All right, next up, part B, find the length of D. Okay, the bottom of the ramp. Find that horizontal distance D here. Jacob, question?
Is the first part somewhere where you would care about units because you're like making it from one unit originally into a different one?
Well, if you leave it like this, it's in inches because your diagram was in inches.
Yeah.
So I would, whether you have it or not, doesn't matter to me.
Okay.
Yeah. All right, thoughts on how I can find D now? All right, here's what a lot of kids think. Oh, I'll do it similar to what I just did in the last one, which is I'll just take this and we'll move it up there because I already know the length. That's not the length of the ramp, though. The ramp extends further back. Okay, that's not the length of the ramp there. All right. So that's a problem because I want to do 18 again, but you can't. All right, so I can't make this out of a right triangle because this is not 18 anymore. Agreed? And this from here to here is not the length of the ramp. It's more than that. All right, we just found more than that. It's this out here. Okay, so I need something better than that. All right, making a right triangle that way is not going to cut it. Sophie, you got something?
You could do like the same triangle you did before.
Okay, hold on. Let me get that bad boy up because I think you're off to a good start. So Sophie's saying, hey, let's get that same right triangle we just used. Yep.
And then you would find the adjacent side.
Okay, so you're now saying instead of finding D, we're able to find, I'll call this Y,
Yeah.
that whole side. Everyone with her so far? We can find that whole side because remember, we knew this was 18. Yep.
And then you would minus 16.
Why 16?
Because 8 was 8.
Everyone see it. This total leg here minus 16, 8 inches and 8 inches will give me the length of D. Everyone see the plan? Yes, no? I'm going to find the whole leg. I'm going to find the whole leg and then subtract out those 2 8 inches to get to D. Yeah, I like it. All right, I like it. All right, so which ratio do I need to use here? We were just told the 18 was opposite. All right, let me talk to somebody here now. I got to change those numbers here quickly. Abby, what's this side, full side we need to find now? That's what, hypotenuse or adjacent? Adjacent, right? So if I have O and A, which ratio do you guys want me to use here? Shroom, going. Aditya, what ratio with O and A? TOA. Tangent. So I'm going to do tangent 4.76 equals opposite 18 over Y. Cross multiply. And then I'm going to divide it by both sides by tangent 4.76. And here's that whole leg, that whole adjacent side. 216.1660169. And if you remember Sophie's plan, she's like, nah, that's not the D, right? That's not D, that's the whole leg. And to find D, I need to subtract out 16, the 2 8-inch pieces, to end up with 200. My math isn't right. Somebody tell me here. 200.1660169. You'll notice I didn't bother, Kira.
You have to divide by 12.
Yep, I noticed I didn't round, right? I didn't round this 200 because, again, got you for a third time maybe. It says to the nearest tenth of a foot, and this is all in inches. This is all in inches. I don't know what your preference is. I always like to do the conversion at the end of the problem because if you don't, everything's got to be turned into feet, including those 8 inches that we subtracted off. And I'm not going to subtract 8 over 12 and 8 over 12. All right, so I like to do all the converting at the end. And that's going to be 16.7 feet. No?
I got something different.
Did you end up with 200 inches?
No, I did cosine with the ramp and then y. Oh, are you trying?
So you're doing cosine of 4.76. But now, are you using 18.1? Because now you're using feet with inches. What did you set up with cosine, Theo? Cosine of 4.76 equals what?
I used 18.
But did you use 8? Did you, and then you did down here?
Yeah.
Okay, so that answer's in feet now. Did you subtract 16 from it?
Yeah.
Okay, but now see you're subtracting feet from inches. Right? Because your answer down here for y is in feet. And you're subtracting 16 inches from it. You got to convert that 16 into feet and then subtract it. See the deal? And then you'll have, hopefully, 16.7. Okay, and that's a great mistake that you made, and for everybody else to hear, you got to make sure you're in the same units. Anybody else here? A little bit tougher, a little bit. Okay, I'm done with day 8. Go to day 9. It was just going to be more word problems using sine, cosine, and tangent. This is day 9. Hey, day 9, still more word problems, except I use 2 new vocabulary words. All right, 2 new vocabulary terms. We're still doing word problems using sine, cosine, and tangent. It's just 2 new vocabulary terms. All right, so read the first one here. We got Scott's eye level is 1.5 meters above the ground, so let's throw that on the diagram, huh? His eye level, so from his eye to the ground is 1.5 meters. Eye to the ground, 1.5 meters. And above the ground stands 30 meters from the tree. Everyone put a 30 somewhere. He's standing 30 meters from the tree. Okay, here's our new vocabulary term. The angle of elevation. Elevate. You kind of think when you're riding up in an elevator, your eyes look up and make an angle. Right? So you're standing on the ground. You're looking at a building, the top of a tree, top of a staircase, and you're looking up, and you are making your eyes are making an angle with the building, or in this case, the tree, and the horizontal coming across. So let me show you how this works. He's looking up at the bird. So he's looking up at the bird. Where's the other side of the angle? It's always the horizontal coming across. So this angle right here is 36. Elevation, I'm looking up at something along with the horizontal line of sight. Okay, so that is angle of elevation. Looking up along with your horizontal line of sight. That is 36 degrees. Angle of elevation, I'm looking up at something. And then how far above the ground is the bird? Okay, how far above the ground is the bird? So bird to ground, what's my distance here? All right, let's talk. Do you see a right triangle that can be formed here? Do we see a right triangle? By connecting his the vertical distance here from the bird to the end of his eyesight. Oh, well, there's a problem. I don't know any sides. Or do I? I need to at least have a side length to do sine, cosine, or tangent. Is there any side I know up there? Jacob?
The bottom leg is 30 meters.
Yep, remember he was 30 from the ground, so this leg here is also going to be 30 meters away. Now, I'm not going to find out the distance from the bird to the ground in one step. I'm not going to be able to do that. I need to do a little extra work. So do you see a side that I can find that would help me? Absolutely. We'll find this side of the right triangle. Now, will that be my final answer? No, I'm going to have to do a little something at the end here with that answer. But at least let's solve for that leg. I got to change that so we're fair now. Okay, let's talk. Where am I going there? There we go. The chia. I got 36 degrees. What's the 30? Opposite adjacent hypotenuse. All right, Jason, good. And the side we're looking for is the? All right, if I have those two, what ratio can I use? Tangent. Good work. Tangent of 36 equals opposite y over adjacent 30. All right, we cross multiply. Tan of 36 times 30. As you're doing that, quick question, is that my final answer? No, why am I asking? You're not rounding. If you're going to tell me no, it's not my final answer, we should be not rounding this value on our own if that's not our final answer. So I'm getting about 21.79 and change for that opposite leg. How do I get the full distance now? The full distance. Violet?
Add 1.5.
Add his eyesight level in. Yep, add in that 1.5. Just a quick check here. All right, it just says round to the nearest tenth. It doesn't give me a specific unit, so we don't need to convert anything. So ground to bird, ground to bird. What are we looking at? 23.3. I always put the units, but I don't care if you do, as you know. All right. Elevation. I'm down on the ground looking up at something taller than me, building. In this case, a tree, a bird on a tree. Great. Questions on elevation. We'll see it again. Now, what happens if the roles are reversed and I'm looking down at something? All right, now I'm on top of the tree. I'm on top of the building, and I'm looking down at an object on the ground, and I make an angle here. We have a term for that. And that term is the angle of depression. Okay, so when I look down on something, I form what's called an angle of depression, but you got to be careful here. Everybody just assumes it's the other angle. All right, everyone just assumes that it's just going to be that angle here, and the answer is no, it will not be. All right, take a peek here at this awesome example. How about this diagram, huh? Big Al watching his friend approach the building. That's kind of creepy. From the rooftop, look at that. Look at those two people there. I can't do much better artwork than that. The rooftop, 16 meters from the ground. Big Al's eye level is about 1.8 meters from the rooftop. So his eye level, about 1.8 meters from the rooftop. What's the distance between Big Al's friend and the building? So everyone see what we're solving for. All right, now let's talk about this depression because it is not the other angle. It is not the other angle. So as we said, depression is looking down. So Big Al looking down at his friend. But depression is looking down with the horizontal eyesight, similar to elevation. That angle is your angle of depression, 40 degrees. Okay, so it's actually located on the outside of the triangle, which brings another problem. All right, so depression looking down with your eyesight level, so it's outside the triangle. Here's the problem we have. You're not doing sine, cosine, tangent with an angle outside the triangle. You need an angle that's actually inside. So how about you impress me doing some geometry? Take that 40 degrees and can you convert it into an angle that would be inside the darn triangle? Something we've learned this year. There's two different ways I can take 40 and put it in the triangle to make an angle inside. Woo! Two different ways we could do this. John, got a suggestion?
No.
Oh, sorry. Abby?
His eyesight is parallel to the ground.
Darn right.
So, opposite interior angles.
I'll take it. I'll take alternate, but go ahead. I'll take it.
Interior angles are congruent.
Yeah. Hey, everyone. If that's 40, that bad boy's got to be 40. Alternate interior or congruent. Did anybody else find a way I could get 40 degrees inside or help me get one inside? Bennett, what's your deal? Yeah, darn right. Look. Forms a right angle. So if you didn't like 40 degrees down there, we could put 50 there. Okay, forms a right angle. Your call. Your call. Let's just make a class decision here. All right, Emma, big job here for you. You want me to leave the 50 or put the 40 I had in? 50. I'm leaving 50. All right, let's go. Ooh, we better watch out, though. We better watch out. Kira, what's the side we're trying to find? Opposite, adjacent, or hypotenuse from the 50 I'm using?
Opposite.
Opposite, good. And how about this little deal here? Oh, that's going to be what side? Adjacent, yep. So I'm going to use what ratio, Kira? Tangent, good. Even if you put the 40 there, you're going to be using tangent just in the reverse order. So tan of 50 equals opposite over, watch yourself here, not 16. Right? It's not 16. Don't use 16 as the side. What do I need to still add to it? 1.8. So actually I'm going to be putting 17.8 in here for that side. If you use tangent of 40, it would be 17.8 over x. Cross multiply. Quick scan. I don't need to round to any. I don't need to convert anything. Just round to the nearest tenth. 21.2 meters. Questions? Oh, let's go. Keep grinding here with it. Another depression one. How's everyone feeling? All right? Good so far? Oh, we even get to some new names and stuff. Gallery of a lighthouse. Anybody ever been into a lighthouse before? Yeah? Nice. Up to the top where the light is and swings around? No? Oh, whoa, sorry. Got to be VIP. All right. Person spots a ship at an angle of depression of 20. All right, depression. Can we draw that in right now? Can we draw that angle of depression from the top of the lighthouse to the boat being 20 degrees? So again, looking down with the horizontal, 20. Depression always located outside your triangle. All right, what else do we have here? The lighthouse is 28 meters tall. All right, so lighthouse, 28 meters. And sits on a cliff that's 45 meters tall. What is the horizontal distance between the lighthouse and the ship? Horizontal, right? Because, hey, if I just said hold on. If I just took out the word horizontal and I just wrote what is the distance between, some of you would say, well, what are we talking about? That distance between them? That distance could be either one. So that's why I wrote in that specific word horizontal. So you know you're looking for that side. All right, can't use the 20 where it is. Bring it inside the triangle for me. You got two options as we just discussed. Bring that 20 inside the triangle for me. Here we go. Tiffany, bring it inside. What do you want to do with it? Okay, you're going to use the 70. You got it. We'll use the 70. So if I'm using the 70, the side I'm trying to find is opposite, and cliff and lighthouse are adjacent. Which ratio are we using to solve for this one now? If I have opposite and adjacent, Catherine, which ratio? Tangent, good work. So tan of 70 equals opposite x. Ooh, whoa, 28, 45. Neither should appear there, right? Got to add them together. What I got, 373. Okay, make sure we use the whole side of that right triangle, just not the parts. And quick scan of the directions. It says nearest tenth of a meter. Whoa, meter. Okay, my problem was in meters, so no need to convert. And just I want to hear from somebody else. Emma, when you have it nearest tenth, let me know. Got it. Unbelievable. Questions? This is my favorite time right now. I'm going to come around and watch you do number 4. There is one word here you might not be familiar with, where it says the pilot reports that the altitude of the plane is 5,200 feet. That's ground to plane. All right. So, if you got your plane here, all right, your ground's down here. From ground to plane is 5,200 feet. Okay. And yes, I will be coming around and judging your artwork. Okay. Yes, I will be. All right. I will be. Look at this right here. How about that? I can't get much better than that, I'm sure. All right, for my plane. Okay, I want to make sure in all seriousness, I want to make sure you can set up the diagram correctly. Angle of elevation, so it's from the control tower looking up to the plane. And yes, you're going to get a large number here. You're looking for the diagonal distance from the control tower to the plane. Correct. Yep. Mm-hmm. Tess, I said a control tower, not a bone. I'll take a blimp, Henry. That's fine. It can be an airplane or a blimp. It's all good. Good, you blimp. What's up, boss? Good to see you. So it just looks like a carrot over there. John, it must be 4th of July at John's airport. He's got fireworks coming off his control tower. Will, control tower, not a mushroom. It's like one of those things Mario gets to get himself bigger. Is that a signal coming from the control tower?
Yeah.
Okay. I follow what you're putting down. Okay, just make sure we have everything set up correctly. Looking for the diagonal distance, which would have been your hypotenuse. Now the thing you had to calculate was this side right here, which is 5,200, your altitude minus the height of the control tower. So hopefully we're using 5,000 there. All right, subtracting those. And now we should have used sine of 7 equals opposite over, 5,000 over x. And then when we cross multiply, I'm getting to the nearest foot. Everything was in feet, so no conversions needed. 41,028 feet. The diagonal distance from the control tower to the plane. Okay. We could do it. Told you we could do it. So we got 8 and 9 tonight. Okay, 8 and 9, and tomorrow's a short day, so whatever questions you have tomorrow, bring them. Okay, because tomorrow's going to be a much shorter day for day 10.
I was taking a photo for you.
Fine time. Don't worry about it.
It's a funny now.